Here we go again. What's up, Monitorama? My name is Dave. I engineer at Fastly, and we are hiring. And I'm here to talk about logging stuff today, but I am not here to talk about Fastly logging stuff. In fact, the solution that I'll describe to you today, I built at my last job, which is a company called SparkPost, which I know seems kind of confusing, but I'm sure that recently acquired jobs are something of a theme in the room, so I'm sure we'll get through it. First, it's important to me that you know that throughout the entire length of my talk today, I'm not going to make you raise your hands or participate in any way. So feel free to relax, sit back. There will be no informal polls of any kind. And if you promise to laugh at the jokes, I pledge to let you keep your hands to yourselves, and we'll be out of here eating lunch in no time. Now, so we built this thing. And to truly sort of comprehend the solution I'm about to present, and especially to sort of understand the reasons behind why we built it, I need to make clear the distinction between two sorts of narrative. The first sort everyone more or less organically understands, I think, which is the story of how it happened. And that's how system logs work. They are a running narrative of what happened to the system in the same sense that the Iliad tells us what happened at Troy. But the other style of narrative, the one that I want you to think about with me today, is the story of how it is. And it's a much more subtle, but in many ways superior way of understanding things. And I think more importantly, as an engineer working with observability tools, I think what you'll find is that you're always trying to discover not what happened, but rather how it is, which I'll talk more about in a moment. But first, to help sort of drive home the distinction between these two narrative styles, I'm going to share a short story from my past, which I think a few of you know is a rife landscape for cautionary tales. In fact, at a past Monitorama, as Jason said, I related a short anecdote about one of my more questionable life decisions, which was enlisting as an infantryman in the Marine Corps around 1993. And in that story, I mentioned that life in the Marines was far more janitorial in nature than I had expected it, and how that surprised me. But there were many other sort of surprising aspects to life in the United States Marine Corps. For example, there was a lot more singing than I would have expected. We were always sort of marching and singing, and we were always, just sort of marching, and every time we marched, we sang, so we were always, sort of singing. And I'm not going to make too fine a point of this, but all of the songs that we sang were grossly inappropriate, like to the extent that even summarizing them today here with you would probably earn me an HR violation trophy. So there was this one song, however, that was very different, radically different from every other song in our sort of soldier repertoire. It used much older English, and no one got murdered or impregnated anyone. And there was only one curse word, and it was a clever and sort of canny and sarcastic song, which is really saying something, because in my experience, the Marine Corps as an entity is otherwise immune from sarcasm and every other form of irony, comedic and otherwise. And I'm not going to sing this song to you today. Shut up. I feel your disappointment. No, I'm not going to sing it. I will chant it at you so that you can get a sort of sense of the pentameter, but I feel like I'm already sort of far out enough on the limb that, we'll see how this works out. It began. Chesty Puller was a good Marine, and a good Marine was he. And he called for his pipe, and he called for his robe, and he called for his privates 3. Beer, 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 said the privates. Merry old men are we. The Army's fair, but it can't compare to Marine Corps infantry. And from there, it sort of proceeds up the ranks in a very sort of 12 Days of Christmas way, where each rank sort of presents itself to Chesty Puller and expresses the fondest desires of its heart. And sadly, I don't remember every rank, but I do remember several up to about the rank of captain. So here are those, the lines that I remember, which is in descending order, which is how the sort of the end of the chorus portion of the song would go. Who's going to drive my Jeep, said the captain. Who's going to dig my trench, said the Louie. Who's going to paint my rock, said the gunny. That's a crock of shit, said the sergeant. I want a 3-day pass, said the corporal. Beer, 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 said the privates. Merry old men are we. The Army's fair, but it can't compare to Marine Corps infantry. And I'm here to tell you this song absolutely and 100% slays every single one of those ranks. Like literally everything you need to know about what happens to a human being when you make them into a gunnery sergeant in the United States Marine Corps is contained in that line, "Who's gonna paint my rock?" That song tells you how it is. And I thought, when I first heard it, that it was radically insubordinate. And compared to the other songs that we sang, whose subject matter, again, I hesitate to even summarize in polite company, I couldn't account for why we bothered to sing it. So I could only imagine that maybe its seditiousness was its appeal. But then one day, I was in a place called the Quackenbush Corridor, and I was hiding on a ridgeline as the forward elements of the United States Army's 101st Airborne Division sort of made camp below us. And it was very quiet in the desert, and I could hear a few of them singing. And y'all, they were singing this song, except they had different lyrics for it. So instead of Chesty Puller being a good Marine, the Army sang "Old King Cole was a merry old soul," and their last line went something like, "Beer, beer, beer," said the privates, "what merry men are we, but none so fair that we can compare to the airborne infantry," which I think we can both agree is objectively inferior to the Marines' version. But it turns out this marching cadence originated as a British nursery rhyme sometime around 1708. In fact, Charles Dickens mentions Old King Cole in several of his books. And it evidently made the jump into the infantry cadence along with the generation who made the sort of jump from children to soldiers at that time. And as far as I've been able to tell, every British descendant military organization, infantry force in the world has its own version of this marching cadence. For example, the United States Navy and Air Force don't sing it because they're flying and floating. They're not infantry. But the British Royal Marines, the Australian regulars, like you name it, they all have their own version of exactly this cadence right now today. And I can also tell you that in every version of the song that I've ever been able to find, the privates, they just want a beer. And I'm willing to bet you anything that marching as a private in the Diocletian army, like 1,000 years before this cadence ever existed, all Sebastian wanted was a beer. Because that's how it is. For every human being, wearing the context of infantry private throughout the history of the world, until today, right now, that's how it is. Life is a temporary state which cycles between suck and beer. And there's no point in dwelling on the suck. So you may as well celebrate what you can right now until you successfully do your job and use your body to stop a bullet or a spear or whatever. So this song really is an oral history, and that's why we bother to sing it. It's an oral history of the infantry. But instead of telling you what happened, who marched where, what rich people sort of won or lost, this song is a song about how it is, which is a far greater truth, I think, that you will agree, and makes what happened ultimately sort of irrelevant. Now, you're on my page, I hope. At SparkPost, we had a very complex MTA called Momentum. An MTA in this context stands for Mail Transfer Agent, not Mail Transfer Authority or Metro Transit Authority. Well, for those of you who weren't with us in the 90s, I'll explain. In oldish times, there was this piece of software called an MTA. It sent email, which was an asynchronous plaintext messaging protocol that robots used to communicate unsolicited advertising to each other. Now, the SparkPost MTA is a very large multi-tenant distributed system. It sends about 25% of the world's non-spam email, so just buckets of mail, and it generates on the order of twice as many logs as it sends mail. So you think about what needs to happen when you send an email. You have SPF and all of this DNS stuff that happens, you get way more logs. So, as an ops person sort of working with this thing, you're constantly finding yourself in the situation where you're reconstructing end-to-end user interaction using logs from this huge distributed system, which therefore means you're winding up spending a bunch of time crafting SSH wrappers around grep, or either that or you're copying logs down locally, which is even worse, and either way you wait and wait and wait on grep to find nothing, usually statistically, which leaves you in the place of kind of not being sure whether the data is absent or whether you're just holding SSH or grep itself wrong. And don't get me wrong, I love me some grep. That's a Usenix organization. But the time and effort that goes into grepping for problems in this environment rarely comes out the other end. So grep winds up being sort of an economically infeasible solution, even though it's free. And which, by the way, many of you don't know, this is how the fine art of artisan sourdough bread making was recently rediscovered. There was a hipster ops guy named Chad, and he was trying to reconstruct events from syslog, and his grep commands were taking so long to return that he literally started studying bread fermentation techniques. Just to stay awake. And his bread got so good that he was able to quit his horrible job in computer land and open the world-famous Tartine Bakery in San Francisco. We owe that all to grep. That story is 1,000% not true, by the way. It's complete fabrication. I just thought throwing some bald-faced lies in was politically topical. So no grep for you. So what do? You move on to Splunk and Elk, as everyone does, and your experience may be different from my experience. I'm trying to be, this is not trying to be an opinionated talk, but I'll tell you that what we found is with anything that we were ultimately paying for by volume, we would wind up in these situations where the data we wanted just wasn't in the tool because it was too expensive to forward and store sort of like every kind of log that our MTA would send. And we just couldn't, we could never get into this groove of accurately predicting what kind of data we would need later. So, and I could talk more about that, but apart from the technical problems we have, I do strongly feel that the contemporary tooling is more or less centered around helping you understand and figure out what happened when what we really wanted at SparkPost was a thing that we could have a conversation with that would tell us how it is. And so let me give you an example of how that whole mess translates into computers before I tell you how we built this thing. 1 year ago, I was sitting in a coffee shop in Bozeman, Montana, staring at this graph when I should have been hiking. The graph represents an order of magnitude increase in bounce messages occurring across our outbound sending tier. And it was forwarded to me from a senior manager who had gotten it in an email report. So I had no context, really, into how this metric was being sourced or what was generating this report. I just had senior management wanting to know why we were suddenly bouncing more messages. So what do I want to know? As an engineer looking at this graph, do I want to know what happened? I mean, it's not really a meaningful question yet, right? Because I don't know anything, again, about this graph or what numbers it actually represents. So I don't necessarily know that anything happened. What I really want to know is this how it is? Are we actually bouncing an order of magnitude more email than we had been a week prior. So I go to our new logging tool thing that I built, and I make an SQL query because I can make SQL queries with our new logging thing. And yes, I discover it actually does look like this is how it is. We're bouncing way more messages now than we were a week ago, and now I have this truth sort of from a source I trust, which is the MTA event logs themselves, right? So as an engineer at SparkPost, I happen to know that we've had this sort of problem before when some top-tier email recipient like a Gmail or a Hotmail implemented some new and aggressive and ill-conceived filtering technology. So like in terms of a single event that creates, massive bounce rates, that's my most likely scenario. So now I'm wondering, is that how it is? So do we have an increase in bounce rates from any of our top tier recipients? So I write this query, and I feel like this is a really good example of giving just a little bit of operational knowledge about how the systems work. An engineer like me can begin to sort of interrogate event log data to discover how it is. So this query is going to give me a 4-column breakdown of the number of bounces per day for each of my top tier email recipients and answer this question, are any of them bouncing more? And I can see that no, that's not how it is. We don't have a meaningful increase in bounces from any of our top tier recipients. So that makes me curious to see, well, what kind of bounces are we actually getting? And now we can start getting into what happened. Like, what is the literal syntax of the top 10 bounce messages before and after this event took place? So I make this query twice, once to see the top 10 most common bounces before, and then again for just changing the period to after. And sort of in comparing these two, I notice a drastic difference. In fact, I notice the second most common type of bounce message after the change date never even existed before this change happened. So I am suspecting that we have a new class of errors. Maybe we added some new logging, or maybe we're logging differently, which I was able to verify with a shout out to the dev team on Slack. We aren't in fact bouncing more email, we're just tracking our bounces in a more granular fashion now. And basically that management report just needs to get updated to reflect our new logging reality and ticket closed. But this is the kind of issue that a production ops team can spend weeks running down. Just trying to prove out negatives, using shell tools or even in a dashboard trying to like figure out, just the right, regex log syntax pattern that will summarize, and account for all of the exceptions, which requires, vastly more domain knowledge. And that's assuming the new class of traffic, like the one we have here, would even be in the tool, which is always a huge if for us. But with this thing we built, you can afford to store everything, everywhere, all the time, like the other speaker said, arbitrarily. And anyone can clear this issue in 5 minutes with 4 like well-placed queries. They don't need to know the logging syntax or much about how the system works. They can read the fields from the schema. And compared to every other logging solution out there that I've used, I do believe that this thing is less complex, easier to maintain, cheaper, and far more accurate. Like I'm a convert, I have the word senior in my title, so I know I'm supposed to be jaded as hell, but I believe that this is the new logging way. And I can hear you like, Dave, you put your logs in a database, like collect your stuff, security will be by to escort you out. But I promise this isn't that. Let's talk about databases for a second. Well, I knocked the water over. And the thing you need to understand is, for the entire length of the history of people interacting with databases, we've been doing this thing where we map our data to a schema at write time. We take our data in one hand, we take a description of what the data should look like and be stored like in our other, and we sort of immediately combine the two, writing the result out to disk in a binary pre-formatted way that strongly resembles a spreadsheet. That's a database. And users can subsequently make queries against this thing because now we have it stored in this schemified, normalized, queryable format. It's a proper database. And I know that this will be a controversial position, but I hate databases. Like y'all, I hate databases. I've never met a database I didn't eventually want to set fire to. And I'll come clean right here now. I am a complete Luddite when it comes to the entire solar system of Paxos database-related chicanery, computer science, whatever you want to call it. So you can believe me when I say I am the last person who would wish a database on anything, much less my beloved system logs. What I'm talking about here is in a completely different galaxy of solutions. Schema on read systems enable us to map our schema to our raw data at query time rather than at write time. So you take your data, but it's never ETL'd into a binary spreadsheet or transformed in any way. It's not queryable in the classical database sense. It's just bytes sitting somewhere on disk in its native format, which can be JSON, raw log files, YAML, whatever you want. The schema itself is just a regular expression or something equivalent, which the system can use as a map to transform the at-rest data into named fields in memory. And so there is no database. Instead, all you have is some metadata that's linking the location of your stuff to a schema that we can use to parse through it when we want to. And then at runtime, we take our user query, and we map the query to the schema, to the data, and we spit out an answer. So depending on the size of the data set and the breadth of that query, we can do that in memory on one host, or we can sort of scale it up to a map-reduced job and use many workers that sort of fan out and process chunks of the data individually. But from the user perspective, the process is semantically analogous to grep, just with a way better syntax for forming queries. So right now, today, as you sit in front of me, if you are an AWS user and you have logging enabled on your load balancers, those ELBs are logging right now to S3. And you could hypothetically point a schema on read query engine at those raw logs and search through them using an SQL-like syntax. Log files on disk is technically the only persistence layer required. Many people would call what I'm describing to you right now a data lake, but I don't call it that because I think it sounds lame. So if you want, you and I can think of it as a write once, read many times data store, which if you think about it is a pretty apt description for the log files themselves. The infrastructure is not complex. We take raw logs from our MTAs, we feed them into Amazon S3, and then we use the built-in AWS query engine, a thing called Athena, to basically query that log data. And I should mention, there's a whole bunch of query engines out there, including both open source projects that you can run yourself, like Apache Drill, and hosted stuff from the cloud providers like Google BigQuery. So you don't necessarily have to implement on AWS like we did. And I think it's fair to say I'm making it sound way easier than it is. In fact, we learned a lot of sort of hard lessons in the process of standing up this data pipeline that's required to stream logs in real time to S3. But I think maybe the first thing we learned is that it's hard to stream unstructured data. And I know I said all you need are raw log files in S3, but in real life, most of the tooling that you'll use expects to deal with structured data. And also because stuff will go wrong, and messages will get dropped. And if you're sending unstructured blobs of text across the wire, it'll be very hard to verify later what sort of got delivered and what didn't. So rather than fighting against the tools at SparkPost, we kind of leaned into it, and we decided to pre-process our log events as quickly as we could right off the systems by shipping them directly from our syslog to a log processing system called FluentD, where they're serialized into JSON objects. This was implemented very simply on EC2 instances using a vanilla ELB to provide HA. So these are log events, so they're stateless by nature. The hosts run just sort of TCP syslog wire protocol, and then FluentD is listening on that syslog port on the other end. While we're in FluentD, we also perform an enrichment process, which is a very common thing to do evidently, where for certain types of API logs, we'll make follow-up API calls from within FluentD to sort of add context to those objects before forwarding them on. So events come out of syslog looking like the typical Nginx style logs. The FluentD router uses a big ugly regex to sort of name all those fields. So we can refer to them inside sort of ensuing FluentD filters. And then we pass them through a series of Ruby filters to transform them into JSON output. And they magically pop out the other end looking like structured data. And that probably sounds like a janky, inefficient mess. But I will say that FluentD's router core is threaded and written in C. And it's just a surprisingly fast and flexible piece of software. And I say that as a person who doesn't enjoy working with Ruby. But I really can't praise FluentD itself highly enough as a stateless event router. Many times during this process, we thought it might be the source of this or that problem, but literally every time we dug into it, we invariably found that it was doing exactly the right thing. So anyway, once our logs are transformed into events, we use FluentD as well to inject them into AWS. Initially, we tried to use the third-party FluentD SNS connector, but both that connector and SNS itself were not buffered. So ultimately, we couldn't send messages fast enough because every single message that you would try to inject into SNS represented a TCP and HTTP handshake, setup, and teardown. So the lesson here was, even though there is no API limit on SNS, we hit network layer limits on our hosts, which basically made SNS unusable for our use case. We moved on. Rather than scaling out unnecessarily, we switched from SNS to Kinesis Firehose, way better fit for this problem. Has first-class FluentD support and a bulk send endpoint, so you can package up your messages and send them in bundles. And then as a bonus, Firehose knows how to write this data back into S3 for you with date-based partitioning built in, which I'd quipped that the solutions were made for each other, but a priori they are actually made for each other. Anyway, at this point, all you have to do is configure Athena to point at it, and you're done. But if you take that home and do this yourselves, I think that what you'll discover is about a month later, your AWS bill has absolutely skyrocketed because of all the stupid expensive AWS Athena queries. Because, surprise, Athena costs, it uses scan-based pricing. So it costs $5 per terabyte scanned per query execution with a 10 megabyte minimum per query, if I'm saying that right. That was a hard lesson to learn. At SparkPost, despite having partitioning in place, a single engineer making a single poorly bounded query could cost the company easily $150. But there's a key word in that pricing definition. I'm not sure if you can sort of spot it for yourselves. But the TLDR is, if you scan less data, then Athena suddenly becomes sort of cost-effective. Impossible, you say? Elementary, I say. With a little thing called a columnar data storage format. So I'm going to now give you a grossly oversimplified and probably for you slightly patronizing explanation of how this works. You don't have to correct me later. It's fine. Imagine you have some data stored in a table, and imagine what happens when you make a query for anyone whose middle initial is J. The query engine basically needs to traverse and parse every line of that, at least as far as the third comma. So that's a lot of sort of gratuitous scanning just to rule out records, right? A lot of scanning through records you're not going to use anyway. And if you're dealing with something like JSON or some other sort of structured data format where you can't predict attribute order, it's way worse. You basically have to wind up scanning the entire file every time. Columnar data storage formats minimize scanning. That's what they were designed for. So what we do is we break the spreadsheet. We take all the columns, we extract them, and we store them on top of each other, along with a very short sort of metadata header that tells us where each of those columns begins inside the file. Then we don't have to search, we can seek. All we have to do is parse that metadata header and find the column start from middle initial. And then we just seek down to that line, and we only have to scan one character on each ensuing line to find those matches. So then we can take the matching records and reassemble them using line number offsets from that metadata header. And we wind up scanning a lot less, and it's sort of just way cheaper and also way faster and way easier on the query engine. And I recognize this is another backpedal away from the statement that all you need are logs on disk. But really, it's just another file format. Just like CSV or JSON would be, our data is still out there on S3, along with all the sort of sanity and safety and non-databasedness that all that implies. Except now it's just much easier for the query engine to deal with. At SparkPost, we implemented this by post-processing our JSON files into Parquet format using Amazon EMR jobs. But today, Kinesis can sort of read those JSON events and write Parquet format directly. So this is all 100% built in today. And then, then you're monitoring the thing. There are CloudWatch metrics for all of these things. We wound up monitoring the pipeline using FluentD's Prometheus output plugin, which is also just nice and very cleverly designed. So I have a time check here, but if I have another maybe 5 minutes, I can share a fun story about how much it actually sucked to build this. Nobody's standing there. Shall we go for it? Okay. So I had this really interesting but invalid assumption, completely invalid assumption. I'll talk fast so we can get to lunch. I'm sorry. Which was that everything in this data pipeline began at the API. So if you can imagine, I'm trying to get all of these systems sort of wired together to the extent that they're pushing 40,000 sort of messages per second without dropping anything. Things are working pretty good. And then suddenly an architect shows up and is like, yo, we dropped an account creation event. So I try to track it back, and it's nope, not in S3 Parquet, nope, not in the S3 JSON, and nope, I don't see it in the Kinesis, and as far as I can tell, nope, 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 nope. This event isn't anywhere. It's not even in the raw system logs. But like, I know this event happened because there's a new account in the stupid accounts creation database. I hate databases. Anyway, so I know the account creation event happened because I have the thing, right? I have the end result. I have the account. And accounts aren't created, obviously, by ghosts or fairies. They're created by account creation API calls. So I do the sysadmin-y, like, yeah, I'll increase this buffer and sort of decrease that one, and just sort of racking my brain trying to figure out what on earth? Why could we have just dropped this one rando message out of the 40,000 that we're pushing? So like, if we were down for maybe a half a second and we dropped 15,000 events, that would be one thing. But just this one event. It just seemed really weird. So I dialed knobs and sort of didn't look up from my desk, and everything was fine for a while, but then a few days later, the same architect is back with another dropped event, and then 5 days later after that, and then again in the middle of the night, and another day after that, and it's just this like aperiodic, completely random non-pattern of these singular events disappearing until the very phrase dropped event becomes like a triggering phrase for me, and there's no pattern or uniformity of the universe, and life's a meaningless expanse of random accidents, and I just want to quit my horrible job and go make sourdough bread. And everyone, including me, heavily suspected FluentD. Like what else? Like what else? What else could be sort of just dropping these, random singular messages like this? So I did some pretty extreme stuff to get better visibility into the router. And then finally I said, I just said screw it, and I nuked it from orbit. I wrote a libpcat program in Go that could just unpack syslog wire protocol, and I surrounded everything with it. Every socket, I just sort of inserted it into between every socket layer I could find. And what I discovered that no, these events weren't, like these new account creation events weren't hitting the data lake, because I called it a data lake, because they weren't traversing the API. Which, like, what? Like, how do you create accounts without traversing the API? Well, it turns out you can. It turns out these events were coming from cloud vendors like Heroku or Azure. So what was happening is you have customers that are like signing up for our product through an app store. And the problem is that these app stores are dictating design patterns that aren't compatible with our API. So they're like forcing our developers into like implementing webhooks or whatever. And so we wound up with all these undocumented code paths that bypassed the API and interacted directly with things like the accounts database. But they weren't used very often. So every once in a while, someone would sign up on Heroku and just completely ruin my life. No offense, Heroku. Sorry. So to account for these, I wound up building a thing that we called IEH force feed, which is basically a second API endpoint that you could re-inject messages that should have gone into the API but didn't initially. And I really felt dirty initially for having written this. But then I went to a proper data conference. I recently went to Strata, and I now know that these hacks are very universal. So now I feel like I managed to self-navigate through some like data engineering hazing ritual. Anyway, this was implemented serverlessly by taking our Ruby Fluentd filters and sort of porting them to Python, and then packing that code into a Lambda, and then packing that into an AWS API account gateway. It's like a day of work. And I'm here to tell you, this turned out to be one of the coolest projects I've ever worked on. It's certainly, of all of the monitoring, sort of off-the-shelf monitoring tools that I've ever had to wire up for a company, which is a considerable amount, it had the most democratic interface. And definitely the widest adoption throughout the company. So everyone from tech support to management was using this thing, which is just really cool and made me feel like we had a huge impact. Anyway, I'm Dave. Thanks for listening. It's rad to be back at Monitorama. I love you guys, my people. Have a good lunch.